Hello students, now I am going to discuss a very important topic in 8085 and that is called interrupts in 8085. So here I will discuss about interrupts in detail. First of all, I will explain what is interrupt, then I will discuss about the classification and then detailed discussion about each interrupt. So what is interrupt? Suppose that you are doing your own work and someone else is coming to you and said that to do his work. What will happen? If you are not in condition to ignore his request, then you have to do his work and then return to your own work to complete that. In this process, you are being interrupted by that person. In the same way, microprocessor can be interrupted by any peripheral device. So for that, the peripheral device sends a signal to the microprocessor which is called interrupt signal. So what will happen? Suppose that microprocessor is performing its main program. It is executing its main program. It is the main program of microprocessor. It is executing it, and at certain instant, any peripheral device sends a signal to interrupt this processor. So when this interrupt signal is received, then what will happen? Processor leaves its main program. It stores the address of the next instruction which is to be executed at a stack pointer, and then program control is shifted to subroutine where the alternate program is given. In the subroutine, the alternate program written is called interrupt service routine. So this ISR is being executed in the subroutine, and at the last, a return instruction is being executed to return to the main program, and then main program will be completed. So this is the process which can occur when an interrupt signal is received in the 8085 microprocessor. So now I am going to discuss step-by-step details when an interrupt signal what should be done to process an interrupt in case of 8085 processor. What I am going to discuss? I am going to discuss step-by-step processes which should be performed to process any interrupt in case of 8085. So to process an interrupt, there is an interrupt enable flip-flop in the 8085 microprocessor. So, any interrupt can be processed if that flip-flop is enabled. Therefore, in the main program of microprocessor, an instruction EI must be there to enable that interrupt enable flip-flop. So what is the need? What is the need of our? The need is there should be EI instruction to enable interrupt enable flip-flop, and that instruction should be in the main program of the microprocessor, and it should be in the beginning of the main program. When interrupt enable flip-flop is enabled, what will happen? Then the microprocessor has to check during the execution of main program that interrupt request is received or not. Interrupt pin, it will check the interrupt pin's status. If the status of interrupt pin is high, if INTR goes high, the interrupt pin is enabled, then the microprocessor completes the execution of current instruction, and after completion of this instruction, it disables the interrupt enable flip-flop. Why it disables the interrupt enable flip-flop? Why it is needed? So that no further interrupt request can arrive at the processor before completion of this interrupt request. Okay, the microprocessor disable the interrupt enable flip-flop after reception of an interrupt request, and it sends an INTA bar, that is interrupt acknowledgement signal. What is the function of interrupt acknowledgement signal? So in the step 4 it is explained. The interrupt acknowledgement signal is used to insert an RST instruction. RST is what? It is short form of restart. Restart instruction which transfers the program control to a specific memory location after execution of step 5. First of all, we should understand this step. When INTA bar signal is generated, it insert an instruction that is called restart instruction. So when interrupt is received at the processor, the execution of the main program is interrupted. It is stopped for some time. So now the execution will be shifted to a subroutine. So what is the address of the subroutine? That address can be provided by an instruction which is inserted in the main program by INTA bar instruction. And what is that instruction? That instruction is called restart instruction. So this restart instruction transfers the program control to an alternate memory location of subroutine. So before transferring this program control to alternate location, what is the need of our? The need of our is to store the address of the next instruction in the main program at the stack pointer. The step 5 is what? Step 5 is when the MUP receives an RST instruction for transferring of the program control, it saves the memory address of the next instruction on the stack pointer using push instruction. What is the use of push instruction? Push instruction stores the address of the next memory and next instruction's address on the stack pointer. After that, program control is shifted to subroutine. In the subroutine, ISR, that is interrupt service routine, is processed. In the interrupt service routine, there should be EI instruction so that interrupt enable flip-flop will be enabled again, so that further interrupt request can be processed after the completion of this interrupt. Okay. After completion of ISR, return instruction is there which retrieves the address of the next instruction in the main program, and the program control is shifted to the main program. So these are the steps which will be followed when to process any interrupt in case of 8085 microprocessor. Okay. So we have to understand these steps so that we can understand the working of interrupt process in 8085. Now I will discuss the classification of interrupt. What are the types of interrupt? This classification is made on the basis of different criterias. Here 3 criterias are considered. First criteria is on the basis of giving an interrupt. What is the meaning of giving an interrupt? It means that how an interrupt signal is initiated. If the interrupt signal is given at any hardware pin, at any pin of the 8085 microprocessor, then that is called hardware interrupt. And if the interrupt signal is initiated through an instruction in the main program, then it is called software interrupt. So on the basis of giving interrupt, there are 2 types of interrupt, hardware and software. What is its meaning? Hardware interrupt means the interrupt signal is given to the pin of the processor, and software interrupt means interrupt is initiated by inserting an instruction in the main program of the processor, like RST instruction. Second criteria of dividing interrupt is on the basis of priority. On that basis, there are 2 types of interrupt, maskable and non-maskable interrupt. What does it mean? It means that maskable interrupt means that can be masked, that can be ignored, that can be avoided. Microprocessor can ignore that interrupt. It is not necessary to service that request. So, but some interrupts are non-maskable, and these interrupt has highest priority. What is the meaning of non-maskable interrupt? That interrupt cannot be ignored. If the such type of non-maskable interrupt request is received at the processor, then microprocessor has to leave all his important work and has to process that non-maskable interrupt first. So therefore, non-maskable interrupt has highest priority. Third basis of classification is on the basis of address given along with the interrupt. Some interrupts has the address of the subroutine along with the interrupt signal. These interrupts are called vectored interrupts. But some interrupts don't have the address of the subroutine where the program control is to be shifted. These interrupts are known as non-vectored interrupts. Okay, so these are the three classifications, three criteria on the basis of which interrupt can be classified into different parts and different types. Now I am going to discuss hardware interrupts in detail. In case of 8085 microprocessor, there are 5 hardware interrupts. What are these 5 hardware interrupts? Trap, RST 7.5, 6.5, 5.5 and INTR. These interrupts can be provided by giving a signal to interrupt pin. These pins are available in the pin diagram of 8085. Therefore, these interrupts are hardware interrupts. These out of these 5 hardware interrupts, 4 are vectored and 1 is non-vectored. INTR interrupt is non-vectored interrupt. It means that it don't have the address of the service routine or subroutine. But all the other 4 interrupts, trap, RST 7.5, 6.5 and 5.5 are vectored interrupts and their address is given here. The address of trap is 0024H, 7.5 is 0030-3CH, 6.5 is 0034H and RST 5.5 is 002CH. Priority order of these interrupt is same here. Trap is non-maskable interrupt and it has highest priority. After that RST 7.5, 6.5 and 5.5 and then lowest priority interrupt is INTR. Except trap, all the other hardware interrupts are maskable interrupts. The properties of hardware interrupts can be summarized in the form of a table which is shown here. This is summary table which gives the different properties of hardware interrupts. Here I am considering 5 hardware interrupts and their properties. I have discussed about the remaining properties. Only I have to discuss about the triggering level. Some devices are edge triggered and some are level triggered. The trap is an interrupt which is edge as well as level triggered both. While RST 7.5 is edge triggered, that is edge sensitive interrupt, while all other interrupts are level sensitive interrupts. Their priority order is this, and only trap interrupt is not maskable, all other interrupts are maskable, and only INTR is non-vectored interrupt, all other interrupts are vectored interrupts. Okay. So these are the details of hardware interrupts. Now I am going to discuss about software interrupts. So what is software interrupt? I have explained earlier. Software interrupts are those interrupts which are initiated by giving an instruction in the main program of the microprocessor. So in case of 8085, there are 8 software interrupts starting from RST0 to RST7. What is RST? RST means restart. When an INTA bar signal is given by microprocessor after reception of interrupt request, this INTA bar signal is insert and restart instruction in the main program of the processor, so that the execution of the main program is program control is being shifted to the subroutine. So this is the function of RST interrupt. So along with the RST interrupt, the address of the memory location to which the main program is to be shifted must be given. The vector address of these RST interrupts, there are software interrupts, can be calculated as this vector address can be given as interrupt number into 8. There are 8 RST interrupts starting from RST0 to RST7, and the vector address of these interrupts can be calculated by multiplying their interrupt number by 8. So this is the table which gives the address of these interrupts. RST0 So this interrupt number is 0, and in decimal form this vector address is 0, and in hexadecimal generally address is shown, it is 00000. For RST1 the address in decimal is 8 and in hexadecimal is 0008. In case of RST2 it is 16, that is 0010. In the same way all the RST interrupts have their hexadecimal addresses, which can be obtained by multiplying the interrupt number by 8. So these are the details of software interrupts. Students, if you have any other query related to interrupts, you can contact me. This is very important topic according to the university exam, and generally notes type questions will be given in the question paper of the semesters. So if you have any query regarding the interrupts, you can ask me anytime. Okay, thank you.